But let's go through our problems on 4.3. The first thing we had to do is find that constant of proportionality. 0 over 0 is 0. So that's the one that doesn't match, right? That is the one that's undefined. If you don't clean any windows, you can't, or you're not going to use any cleaner. And we start at the origin. So we're not going to worry about that in terms of our constant. So now we have 16 over 2, 24 over 3, 32 over 4. I'm feeling a pattern here, right? And no matter what point on the line that I find, it's always going to equal 8. Okay, so our constant of proportionality is 8. And what 8 is, it's our unit rate. So K equals 8, and it represents, like I said, it's our unit rate. And in this case, or in this problem, it is ounces per window. So we're going to use 8 ounces of cleaner for every window that we clean. How would this look? Well, it's proportional. Start at origin, right? Linear, okay? These are what things that it's going to look like on the graph, right? So great job on that problem. Now we're going to go ahead and do the problem for 4.4. The weight of a person on Earth varies directly as the weight of the object on the moon. 150 A 150-pound person would weigh approximately 25 pounds on the moon. Define the variables and write an equation to represent the relationship between the weight of an object on Earth and the weight of an object on the moon. So what do we know? You're 150 pounds on Earth, you're 25 pounds on the moon. So I'm just going to explore this relationship. Actually, I'm going to use kind of that table method that we used earlier. So weight on Earth, weight on moon, and we're going to use E for Earth and M for moon, knowing that we are talking about weights, okay? So if for every pound that I weigh on the moon, I weigh a certain number of pounds on Earth, and I can do that by taking my 150 and dividing it by 25. And I know that there's 6 25s and 150, so for every pound that I weigh on the moon, I weigh 6 pounds on Earth. Okay, so M equals weight on the moon, and if I multiply that times 6, I will get our weight on Earth, or E equals 6M. Okay, so that's our equation. These are our variables: moon weight, Earth weight. All right. Identify the constant of proportionality. What does it mean? 6 is the constant. K equals 6. It represents 6 pounds of Earth weight per every 1 pound of moon weight. All right, we'll go ahead and create a graph for this, right? So we can say moon weight is our dependent variable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then we can say our Earth weight is our independent or our dependent variable. And we should always put like pounds on that. Be very descriptive, right? Okay. And then I'm going to go ahead and count these by 6s because why not? That's our rate, and it'll describe everything that we're working on. 18, 24, 30, 36, 42, and so on. And then I could just go ahead and plot these points knowing that, A, this is going to be a continuous graph, right? Because you can be a fraction of a pound. Okay, so it'll be continuous, and no matter how much I create the weight, I can do this. If I wanted to, I could have done 1, 2, 3, 4, 5, 6. That would have made it a steeper line. So it all depends on how you build your graph out, what it's going to look like. But what we're really doing is we're looking at the relationship between moon weight and earth weight. So our graphs might look a little different based on how we label those axes, but knowing that every moon pound is 6 earth pounds, you're good to go. Awesome job. I hope you have a wonderful, wonderful rest of your day.